Hello, this is Mr. Huff, and while you guys are working diligently on the piggy thing, I wanted to do a quick study guide or study review for you so you kind of know what to be prepared for on our adventures on Friday. So, if you look at this diagram where you have a force applied at an angle, and if the device is moving forward, you should be able to describe all of the forces interacting and what would have to happen to make it move forward if there were friction involved. If you can do that, you've got that question. There will be some questions about free fall, so imagine like this hand throwing this block straight up in the air and what would happen to it. And what if it was, maybe different sized blocks? What if there were smaller blocks and bigger blocks? What would happen if they were thrown at different velocities? So be thinking along that line. Imagine, if you will, that you are a spaceman in this rocket and it's about to take off. So you would need to be able to construct a free body diagram and tell me what happens to thrust and the force of gravity and what kind of forces you would experience if you were the little guy in the rocket right here. Hi, I'm in a rocket. Suppose you had a block trying to slide down an inclined plane. How much force would you have to apply on it to keep it from sliding down? That would be something that you should be able to think about. So this is, once again, start with the free body diagram. On this test, I expect you to write all over it, so you do get to write on the test. Consider, you need to be able to look at different kinds of graphs, like distance versus time, velocity versus time, and acceleration versus time, and identify which ones are the same, describing the same motion. So if that doesn't sound familiar, go back and look at kinematics where we looked at the different kinds of graphs. Two different scenarios I need you to consider. These are Atwood machines. What if you had different masses, different size masses here, and what would happen if what happens to the acceleration? Which one would go the fastest? If you had more masses or smaller masses, what makes the most difference? Think about the situations where the difference between them is the same and the difference between them is great. So if you understand how masses and acceleration work together, then you should be in good shape on that one. The second one is an Atwood machine that has equal masses, and we add a little mass down here. How would you find that acceleration? Okay, so starting from equilibrium, attach another mass, what would happen? This is a question that is about trying to find the acceleration due to gravity. When the person drops the little cube here, it's going to start a timer, and when it hits this plate on the ground, it's going to stop the timer. And you can also use this meter stick over here to measure the distance. So if you know distance and time in this situation, how would you find the acceleration due to gravity? This is a tire. You need to figure out how traction works. Think about which way the tire is being turning and which way the force of friction is acting on it. One of the things you really need to think about is an axle driving the tire, making it spin, or is the tire just being pushed forward and coasting? It's not connected to the engine at all. Does that make a difference? So think about that. The force, the direction of the forces, and which way the force of friction would point. For these problems, assume that gravity is 10 meters per second squared to make your math easy, so you can spend your time focusing on concepts rather than the 0.2 difference between 10 and 9.8. So this is something they used to do in AP tests all the time. We will continue using that for these questions. Consider these pulleys on strings and pretend these are three equal masses. Think about which ones would have the most tension and the least tension. And compare these two scenarios. You have equal masses on a frictionless surface or a surface with friction. In one scenario, you're applying a constant pull down by, gripping the string and pulling it down with a constant force. And on this one, you attach a mass, a small mass that makes the other mass move. Assume that the weight of this mass is equal to the magnitude of this pull, and compare those two as far as acceleration. And if you can think deeply about those questions, you will do well on this exam.